First of all, this talk has a lot of frightening images, so if your heart is weak or your blood pressure is high or something like that, just tell it now and I will stop straight away and we can go to lunch directly. If not, we are talking about Zombiecode, or better, how to survive a zombie apocalypse if and when it happens. But first things first, I'm Marco Cedaro. You can find me almost everywhere online as Chadmax, apart from YouTube and Pinterest, I believe. Don't use that very much because my nickname is taken. I work for Shazam, so later on you can try to sing to me and I may try to discover the song you're singing. And I organize conferences in Italy with From the Front. There is one more thing that I have to tell you about me. I'm strongly opinionated about stuff, and it's a gift and a curse. So don't judge me about the content. Let's talk about it. I know that I may say something that is maybe not shared, but it's the way I feel about stuff. So, zombies. Everyone knows zombies, right? It is about brains. They want to eat your brain. But what is Zombiecode? So, Zombiecode, in my definition, is not definitely that code. And by that code, I mean code that is not getting executed anywhere. Zombiecode is code that is actually in production, that is run. But how can we define what Zombiecode is? So a lot of people wrote books about how to identify zombies. I won't take that amount of time, but what I can tell is that the Zombiecode, first of all, seems harmless code. So it seems that you can control it. But actually, when it's not just a few lines of code, it's not harmless at all. And it will eventually hit your brain. And it will hit your brain during estimation, because you won't be able to tell how much time will it take to add a feature or something. During debugging, and during development as well. It is, thank you. So it is dumb code, actually, and it will make you dumber during all these steps of your work. Hopefully it's not too late. I hope so for you. And there is one cool thing about Zombiecode that can help us identify it, and this is the smell. So Zombiecode has a lot of smells, and we can we can be able to discover that it's Zombiecode because of the smell it makes. I can tell you some tips. So for example, your code should be appealing. When you look at your code and you see methods this long, it smells. When you have this amount of ifs in a method, there is something wrong. By the way, this is a method that I took from a jQuery library online. I'm sorry, I didn't mean to judge people. I'm judging the code. I hope that no one will be frustrated about it. And then comments. Are comments a bad thing? Well, your code should talk to you. So if you look at something like this, which is code that I wrote for the 140 bytes contest. I don't know, you remember it? It was like to put in a tweet a working library. Yeah, it worked for the trick, but it doesn't really make sense to anyone like this. Well, I bet that looking at this code, if you have a few minutes to go through it, you will understand what it does. This is the not minified version of the previous one. So yeah, don't do that now, but I mean, don't use comments as an excuse to write bad code. There are a lot of use cases in which comments are good. For example, when you have to explain an act that you cannot avoid. This is CSS, obviously, not JavaScript, but anyway, that's a good reason to comment code. To generate documentation. If you have public APIs, you want to be able to give a proper documentation to it. That's the way. And to-dos, to remember that you missed something, or there is something that you want to refactor in the future, or something like that. Don't use code again as an excuse. And then, your code should have boundaries. And by boundaries, there are a lot of meanings. One of them could be the single responsibility principle. So, your library, your snippet, your function should do just one thing and do it well. Don't have blob libraries that does all that is supposed to be happening in the page. Use one thing doing the proper way. Oh, by the way, this axe is produced by a Sweden company, And they produce just axes. They started in 1902, and these axes are guaranteed for 20 years. Best weapon ever for zombies. Aimed ahead. No global pollution. That's another kind of boundary that your library should have. So don't, also zombies can tell you that toxic water is the real threat. So don't pollute the global. And then no coupling as well. This is another kind of boundary that you can recognize in your code. No one wants baby zombies, trust me. So no coupling at all. And there are other things that I can tell about. I'm not going through all of them, but these are definitely signs that your code may need refactoring. So we already saw long methods, but also deep level of indentation. I don't want to take out fancy name like cyclomatic complexity or stuff like that, because it's not rocket science, you know. It's just look at your code. If you are 4 or 5, maybe also 3 levels of indentation, then you may do one. Do something. If it's hard to tell what your library does, if you look at your code 6 months later and you don't have a clue of what is happening, if it's hard to take the library out of your page and put in another page, it's another sign that your code is getting to be a zombie. Hardcoded style or templating. Logic block duplication. Those are the basics of refactoring. And callback hell that we saw this morning, I believe. This is another sign that you may have to rework your code. So now we have some clues how zombie code could be like. What we can do about that? Play cool. Play cool. Quarantine. Most teams are trying to stop further spread only through quarantines. It's a good short-term solution, but it won't prevent long-term population loss. There are 2 important information in this article. One is that it's a good short-term solution, and the other one is that it's a short-term solution. And I mean, it's something that you should do, but don't stop there. Are you familiar with the broken window theory? Do you? Sociological theory? So basically, it's a theory that states that if you leave a building with vandalized windows or something like that, the progression of vandalism will be faster than if you fix it. And this was kind of demonstrated with 2 cars left in 2 neighbors in LA in the 70s. One was degraded neighbor, the other one was a fancy one. And the car in the degraded one got vandalized very quickly, and the other one wasn't. And after a while, one of the scientists went to the fancy neighbor, vandalized the car, and suddenly everyone started vandalizing the car also in the fancy neighbor, which is kind of weird, but it tells you that if the environment and the people thinks that something is not important and one cares about that, eventually they will start not caring as well. There is also an article on Coding Horror by Jeff Hatwood that tells, don't leave broken windows, bad design, wrong decision, or poor code unrepaired. Fix each one as soon as it is discovered. Programming is insanely detail-oriented, and perhaps this is why. If you're not on the tops of detail, the perception is that things are out of control, and it's a matter of time before your project spins out of control. Maybe we should be sweetening the small stuff. And I totally agree with this sentence. We should be sweetening the small stuff. We should care about that. We are not supposed just to leave things as they are. So isolate the zombies, and we can do that, defining rules. It's quite important that if you're working in a team, but also if you're working by yourself, you define rules in order to have your code polished and clean, and maybe that seems to be written by one person. You don't want to have something like that. You don't want to have brackets on the new line and other brackets not on the new line. Functions with underscore instead of camel case or Pascal case or whatever you want to use. Camel case. Or random spaces, new lines. You know, this is something that on long term will degrade faster. So define your rules. It doesn't matter that are shared to everyone. It's important that you share that with your team. And you have tools to enforce the use of these rules. So lint is one of them. And this is something that you can do straight away in your zombie libraries. You can start linting your code. It's a quick process, and you can have that under control. And the cool thing about that is not control freakness. It's not that you want control on things. You want to delegate this control to a machine, okay? So that you can care about the important stuff that you're doing in your code, for example, the logic. So it's not about being a control freak. It's freeing yourself from being a control freak. And then start testing your code. Again, this is something that it could be hard on libraries that are already there. But it's something that you can do straight away for new libraries. So do that. Why not? Unit or functional? Well, it's a good question. Do both. So functional is nice for older libraries that you cannot cover on unit tests because they are designer built, and unit is the best thing to do anyway on your new libraries. So there is this weird thing in JavaScript. How many of you run tests actually on this JavaScript? How many people are using testing frameworks? Okay, not many. Okay. So in JavaScript, the funny thing is that the unit test, by definition, should be something like you're testing the smallest logical unit without any dependency. The thing is that in JavaScript, we have a lot of dependencies that we cannot get rid of. Yeah, well, we can mock the DOM, we can mock the style or whatever, but it doesn't really make sense. So at some point when you're unit testing your JavaScript code, you get to test the user input and what happens when the user clicks something or stuff like that. And obviously I'm talking in the browser, not in Node. I'm talking definitely in the browser. But this is kind of functional as well. So there is this, it's not that neat, the difference between unit and functional. So anyway, do both. And it doesn't really matter which toolset you use. It's plenty of them. I mix a lot of stuff that doesn't really make sense one with the other. There are runners like JSTest Driver Buster. There are testing frameworks like Mocha or Jasmine. The point is, it's not really important how you merge them and how you use them. There is no silver bullet in that. I personally use this right now with a runner that I wrote myself. So there is a grant that launches a runner on Phantom.js and the tester I wrote in QUnit. The important thing is that this is something that is automatable, so that you can get to a point in which you commit your code and the machine does the magic and tells you if your code is good or not. This is quite important in bigger teams, most of all, because when you work with other people and a lot of people does a lot of commits, shit happens. So make it part of the process. And the process is not just the technical side of it. There is estimation in which you have to consider testing, because testing, especially at the beginning, will require sometimes more than just writing a library. Code review. Do code review. It's really important to do that, to enforce a style and a rhythm to the team. And involve people. Because you're not an island, we know that. Fear the leaving, kind of. You're part of a team, probably. How many of you work alone? Okay, almost, yeah, a couple of people, so almost every one of you is part of a team. And that don't mean just the dev team, so there is an environment around you. So, do you recognize the movie? Is this a movie that was heard in Belarus? I mean, the Shaun of the Dead? Yeah, okay, great. So, there are the QA guys. The QA guys are by definition, the people that cares about quality, the quality assurance. So, you have to work side by side with them in order to achieve a better code and better functionalities. And they can be helpful, really helpful in helping you covering the old stuff so that when you refactor your code, you don't screw up. So bond with them. They're not the bad person that tells you that your code is not working. You should work aside them. And then DevOps, the tough guys. Sorry. So it will be literally, I'm not so, I don't know if I'm allowed to say that, but it's a pain in the ass to work with the DevOps most of the time, because they don't really understand why you are playing with that JavaScript toy you have no control what they have. But anyway, they are the guys that gets the call at the 2 a.m. when the web is down, the website is down, so don't blame them. And they can really help you in building the automated process, especially if you are not that into tools and build machine, weird stuff like that. And then, last but not least, the product owner. She doesn't care about code, okay? She cares about business goals, product to be released, feature, the sprint to be closed in time. So you have to bring numbers, not theories. Don't tell her, my code will be better. She doesn't care. Try to find a way to prove her that your code will be better. Doing tests and having quality code means that you will be possibly faster in your sprints if you're doing agile or whatever you do. So if you're faster, she will recognize that. But, you know, she can be helpful as well, because as her role is to push you delivering, she will focus you on functionalities and not to refactor for the sake of it. So one of the things that happens sometimes when you start doing refactoring is that you let it go and do just refactoring for a while until your code seems, wow, now it's amazing, but it's too late to deliver. I mean, your code, it's important, it is amazing, but still, you have deadlines, you have business requirements, you have your payroll to get it, and you know, if the company doesn't earn money, the payroll doesn't come. So. There are other people in the team as well. They are usually the ones that dies first in the movies, but juniors and external lobbyists. So the juniors are quite important in the team because they will be the team of tomorrow, and you have to teach them, unless you are a junior. But, yeah. So teach them. Code review their code review your code, because, oh yeah, next step. Because they will help you keeping it simple and trying to involve them in the process as well, because it's important that the process is simple as well. Because again, in 6 months, you may have to introduce a new tool, and if your process is completely understandable, then it will require a lot of time to do that, and it doesn't really make sense. External lobbyists. The external lobbyists, I try to explain who they are. The marketing guy, the legal guy, HR that requires something fancy on the requirement on the website. So, is the people that is going directly to you asking for something? The answer is no. They will slow you down. They will make your brain more prone to be hidden. You just have to redirect them to the product owner. The product owner is the boss. She decides what it's in priority and what's not. Kill them all again. Nothing is impossible to kill. But a goal without a plan is just a wish. And so, design for your goal. That's it. Without requirements or design, programming is the art of adding bugs to an empty text file. This is amazing. It's not mine, it's not mine. This sentence is amazing to me. You have to design for your goal. You have to have clear in mind what's the reason why you're writing code and what's the goal you want to achieve with your code. In the next few minutes, I will try to give you some example of architecture design or something like that that you use in order to try to get rid of the zombie code in a better way than just quarantine it. The first one is the modular architecture. Any one of you knows this slide? I stole it. No? Oh, okay, yeah, someone. So it's Nicholas Zaka's scalable JavaScript application architecture. It's quite simple. It seems complicated and whatever, but it's quite simple. So you have a module layer, which is basically different libraries that contains the logic of the functionalities that you have in the page or in your application. Each of these modules is totally sandboxed, and it gets to be something like this. So you have a module that has an init and a destroy method that are the only public APIs, and a sandbox injected. That's it. On the constructed function. The sandbox itself, it's the only thing that the modules know about the whole architecture. So they don't talk each other, they don't talk to the rest of the architecture, they just have an API on the sandbox. So it's quite important that the sandbox is well-reasoned and has a consistent interface because it's the only thing that you will access from the models. So for example, in this case, we have a sandbox get user, which is the only way that every model will be allowed to access the user data in our application. And then there is application core that basically manages the life cycle of the models. So you have a core register, a core configure that injects the configure object in the init function, a core start and a core stop, so basically everything that is needed in order to manage the life cycle. And then a base library, jQuery, UE, whatever it is. It's quite simple. You know, when you're coding it, it will be a little harder at the beginning, but it's a way that you can do something, isolating features, maintaining the single responsibility principle, and sandboxing and not having weird stuff going around. There's another pattern that is quite interesting, and is the event-driven pattern, that it's kind of integratable with the thing we saw before. So for example, in this case, this model uses a layer, so it opens a layer on the page saying an error occurred. What if, instead of that, we could do something like this? So sandbox publish error. In this case, we will have a sandbox subscribe that basically attaches this function to this channel, and when this channel gets something published, a message gets injected in the function, and you can use it. This has some advantages, rather than just calling the layer straight away. One of them is that you have a semantic overview on what's happening, so when you read through your code, you see that, oh, an error. There is flexibility, because you can just change the implementation of this thing straight away in this model, or unplug this model and put another model that will handle the error in another way. Maybe you have a mobile application with the same code base, and you don't want a layer to appear on the mobile phone, you want something else to happen, then that's it. You remove this model, put another one, and you're done. Over-engineering, I have my colleague there. Every time I talk about this stuff, he says it's over-engineering. No, it's not. It's defensive design. Every time you start thinking about something, you have no clue where your code is leading to, and this is a way to preserve yourself from know later on that you screwed. Again, Zakas is kind of my mentor. I love him, not in a bad way. So, AMD. We have heard about AMD before, asynchronous model definition. So this is kind of a normal code base, so you have jQuery, Mustache, and a lot of files and a lot of dependencies. And so your script may rely on plugins, on Mustache itself, on jQuery, all of them. And this is pretty weird to manage. So the old way to do that is this one. Blocking scripts, difference between production and development, one bundle out of files. Everyone saw that, right? You have that in your code base, no? Raise your hands who have seen something like this or have done something like this before. Come on, how do you deal with that? Really? Oh, I'm amazed. And then namespacing, again, you have your core library that will define the namespace and you don't want to pollute it, so you plug the namespace in the namespace or you... How did you do that? I want every one of you coming to me later on and tell me how to do it. So the other way to do that is AMD. So there is a define function that takes an ID and a dependencies as optional, and then the factory function. And this is an example of a model we can write, and it could be written as this, since the dependencies are optional and everything is static. Anyway, you're defining a model that is called appconfig because it matches the name of the file. if you don't explicitly put an ID of the module. And then this is the object that gets defined. So you can use it straight away, putting it as a dependency of another module. So in this case, we are requiring as a dependency the app config. It gets injected during the definition of this other module, and you can use it straight away. This module itself, it's app my product, and it returns a constructor function that takes an ID and returns an instance with the method getProductURL. And so there are many ways to load these modules. One of them is require.js, which is the only one that we cover, but there are really a lot of loaders out there. And our app main could be something like this. So we require the app main, which himself will load jQuery and app my product and use it straight away with the constructor. And the dependency with the previous app config will be automatically resolved by require itself. So at the end, you get your thing working with just one line of code, no matter if production or development, because you can bundle the code with the require optimizer server side, and it doesn't really change what is going to happen in your HTML. It's just that the app main will be the bundle of all dependencies instead of just one file requiring some dependencies. If you don't bundle them, you will have HTTP request for every dependency you require up to the chain of every module. If not, just the bundled version. I played a little bit with it, and I made myself a mixture of the scalable architecture and the AMD. So there is this definition of a module instead of the core register here, and this is the module constructor with the init and the destroyer, as we saw before from the Zakas architecture. The sandbox has already subscribe and publish methods, and this is how it works. So you have the requirement of my library, core start with the configuration in line, and core start attached to an event, so that module will be loaded just when the event is raised. Play with it, please. Just have fun. But it's not a silver bullet, because there is no such thing. Wow. Happy endings. If you want an happy ending, that depends, of course, on where you stop your story. The thing is, you can run and you can hide, but you're going to write shitty code anyway. Oh, sorry. You're going to face shitty code anyway. Because you will meet one day your younger self or his code, and it will be shitty code. You will, Zombiecode. You will have to deal with a junior that wrote a bunch of crappy code. You will change your job and go to a company which has a legacy code base. Anyway, you will have to deal with that. So just embrace it. It will happen, okay? The thing is, it should get to a point in which you don't improvise, okay? You should learn to know how to deal with it. So today I try to give you some tips, but figure it out yourself, okay? There are a lot of talks out there, a lot of videos, a lot of tutorials how to deal with refactoring. I didn't want really to go through examples because I think that it's plenty of them. The thing is, you have to know how to deal with it until you master it, okay? That's the most important thing. In any case, ever, when you have to deal with Zombiecode, just remember, aim for the head. I'm done. Thank you. If you have any question?
Здорово иметь такой доклад, метафоричный с одной стороны и очень практичный с другой стороны. Будут ли такие же метафоричные вопросы? С ссылкой на фильмы.
If you want, you can tell it in Russian and listen to translation, it's fine. I don't
English is fine.
Okay, cool.
One of the debatable questions is when to write unit tests, before or after implementation. What is your opinion?
Okay. Actually, it's up to you. I mean, I'm comfortable writing it before because it helps me defining the design of the library itself. Because sometimes when you write it afterwards, you get to a point in which you have dependencies or stuff you cannot inject, and you get to a point in which something is untestable. While if you write that up front, you design your library to be tested. But I get that maybe not everyone is used to test-driven development, so it's really up to you. Again, in my opinion, it helps you designing libraries, so I'd say before. But it's not a shame.
It's very difficult to define what functionality you will have. For example, if you don't actually know how to implement something, but you should write tests for it, it's very difficult.
Yeah, that's when stuff like Jasmine or behavior-driven frameworks helps you. So there are frameworks that makes you think about the feature and try to satisfy the feature itself rather than logic. So it may help you defining what's the need. If the problem is that you don't know the feature, then that's another kind of problem. But if it is just about implementation, there are tools out there that can help you in that way.
Thanks.